my dear students, welcome back to my channel. My name is PrachiSharma and in today's session we are working on important questions of hydrogen chloride. This video would be in two parts. That means all the important questions of hydrogen chloride chapter will be covered in two parts. One part is already there on the channel. This is separate two parts because that part was majorly based upon one marker questions or single word questions and answers. These two parts are entirely based upon all the board questions that you may see in the past 10 years. So by watching these two videos, you can rest assured that you have covered all the PYQs for hydrogen chloride. So without wasting any time, let's get started. Alright students, let's get started with today's session. So the first question that so first of all, if you have not covered this chapter, then there is a hydrogen chloride mind map that can help you revise the entire chapter in just 20 minutes. So make sure that you check out the mind maps on the channel. It's a consolidated way of revising the particular chapter in about 20 and at max 30 minutes. So if you have any confusions about the chapter, you can check out that video. Now, this is a question series with an assumption that you do understand the chapter and you are here to practice them out and understand what kind of questions may show up in the exams. So let's get started with the first question. The first question says that give reasons for the following, and the first is hydrogen chloride gas cannot be dried over quicklime. So why is that? That is because hydrogen chloride gas ends up reacting with quicklime and it ends up forming calcium chloride. So that is the reason we do not dry hydrogen chloride over quicklime. Another important thing is that I am not writing the answers. This is more like a discussion so that in less amount of time we can go through more questions. So let's move ahead to the next one. This one says that refer to the flow chart below and give balanced equations with conditions, if any, for the following conversions A to D. Okay, now this is these type of questions are very popular with ICSE board. So if you can see, you have sodium chloride, then you have hydrogen chloride, then on that side you have iron chloride, ammonium chloride and lead chloride. Whenever we start such a question, my suggestion always is to understand what can happen or what you can react that particular compound with to get your output. Now, majority of the students would directly try writing the equations, but before you try writing the equations, always try to solve it mentally. Like what can you add to sodium chloride so you end up getting hydrogen chloride? So sodium chloride, if you react that with H2SO4, that is sulfuric acid. So I can write sulfuric acid here. Because if you end up reacting it with sulfuric acid, you end up getting hydrogen chloride. So that's there. Then from hydrogen chloride, you are trying to reach iron chloride. So what will happen? So what will you react hydrogen chloride with so that you get iron chloride? So what you can do that is, you can react hydrogen chloride with iron, that is Fe. If you react with that, Fe will combine with chlorine to give you iron chloride. Okay, so over here you can react it with Fe. Now moving ahead to the next one, you have you need ammonium chloride. So for ammonium chloride, simply react it with ammonia. So NH3. Then from hydrogen chloride, you are trying to reach lead chloride. Now instead of reacting lead directly, what my preference would be to react lead nitrate with it, because in that case you end up getting nitric acid and along with that you get lead chloride. So in this case you can react it with lead nitrate. And why I am taking this particular example, because this is already there in as a part in your nitric acid chapter. So that's the reason I'm picking that up. Now let's start writing the equation. So when I look at the first equation from sodium chloride to hydrogen chloride, okay, so that means NaCl, and then you are adding sulfuric acid H2SO4, you end up getting NaHSO4 plus HCl. And the condition will be below 200 degrees Celsius and your H2SO4 should be concentrated. This is the first equation. Then from hydrogen chloride, you are trying to reach iron chloride. So we are reacting Fe plus HCl, that gives me FeCl2 plus water, plus hydrogen. Then we have ammonium chloride, so ammonia. So NH3 plus HCl will give me NH4Cl. And the last equation would be lead nitrate. So PbNO3 whole twice plus HCl will combine to give you PbCl2 plus HNO3. And that's it. Now let's move ahead to the next question. Choose the correct answer from the options given below. Hydrogen chloride gas, being highly soluble in water, is dried by what? So always remember that it is dried with the help of concentrated sulfuric acid, and anything else other than that is not used because HCl has a high chance of reacting with that particular compound. So that is the reason concentrated sulfuric acid is your correct answer. Now let's move ahead to the next one. Now the next says that in the lab preparation of hydrogen chloride, in the lab preparation of hydrochloric acid, HCl gas is dissolved in water. Draw a diagram to show the arrangement used for the absorption of HCl in water. So a lot of students, what they do is they make the entire apparatus. That means they make the whole apparatus in which you have HCl gas being produced, and then you have the inverted funnel arrangement. You don't have to make the entire diagram. You only need to show it from where you have HCl gas being produced. That means only the inverted funnel arrangement is the answer in this case. So let's draw that. So I'm just going to draw a very rough diagram. So you'll draw something like this. This is your inverted funnel arrangement. You'll show that HCl gas is coming from this end. You have water, and then you show that HCl gas, and then this is water, mark HCl gas, and mark the inverted funnel. So this is your diagram. Okay. Now let's move to the next part. Why is such an arrangement necessary? Give two reasons. Okay. So it's very important to understand these reasons. The first is to prevent back suction. Now you do understand by now that HCl gas is highly soluble in water. So what happens is that if you use a tube arrangement, the speed with which HCl gets absorbed in water is pretty high compared to the speed with which it is being produced. So from behind, the HCl gases that is coming is pretty low in amount, but it is getting dissolved very fast. So because of that, what happens is that HCl gas dissolves in water and it creates a vacuum in the tube. To cover up that vacuum, water will start rising up into the tube. So that is the reason we do not use a regular tube, but we use an inverted funnel arrangement. Because in this case, water will absorb all the HCl gas. It will rise up into the funnel and then drop down. So it won't get back sucked into the tube all the way. So that is your first reason, to avoid back suction of water. And the second one, you can say it provides a greater surface area for the absorption of the gas. The gas gets more or larger area to get in direct contact with water to get dissolved in water. Now let's move ahead to the third question. Write the chemical equations for the lab preparation of HCl gas when the reactants are below 200 degrees Celsius and above 200 degrees Celsius. Students, this is a favorite question for ICSE board. They ask this question a lot in very different forms. So this can be asked as a single question that's just only for below 200 degrees Celsius. They can ask you the reasons why you have to maintain it below 200 degrees Celsius. XYZ, you can get this question in many forms. So let's quickly write the reaction. So when I am at below 200 degrees Celsius, I already wrote the equation above in one of the questions. That was NaCl plus H2SO4 below 200 degrees Celsius. You get NaHSO4 plus HCl. And when you have above 200 degrees Celsius, you have NaCl plus H2SO4. Above 200 degrees Celsius, you get Na2SO4 plus HCl. Okay, I am not balancing the equations. You can balance it on your own, and if you have any doubts, you can definitely reach out to me either in the comment box, or you can reach out to me on the Telegram channel, or you can also write me an email on psclassesicsc@gmail.com. So let's move ahead, students. The next question is, the diagram below shows an apparatus I don't think the diagram is attached here. So I'll just quickly draw the diagram for you students. So it says the diagram below shows an apparatus for the lab preparation of hydrogen chloride gas. Okay, so let me just draw what the apparatus would look like. The apparatus is a very simple one. So you have a round bottomed flask like this. You have tube, thistle funnel that's coming in, and then you have a small tube to carry HCl gas, and then you have the collecting jar here. Okay, so they have marked that this is hydrogen chloride, and they are asking this is A, and over here there is some salt. They are asking this is B. Okay, now let's look at the questions. Identify A and B. So A will be concentrated sulfuric acid and B will be NaCl. So that's your A and B. Now the next part of the question is asking, write the equation for the reaction. So we have just covered the equation in which it was below 200 degrees Celsius. That is the lab preparation for HCl gas only. Now move ahead to the third part. How would you check whether or not the gas jar is filled with hydrogen chloride? So what you can do is you can bring a glass rod. So once you think it is full, you just have to confirm that. So you have two ways of confirming that. So the first would be that you can see fumes of HCl gas coming out, white fumes or whitish fumes. But if that's you can't see that, other method could be that you bring a glass rod dipped in ammonium hydroxide solution over it. And as soon as you bring it near the mouth of the jar, you get dense white fumes that actually get everywhere, and this confirms the presence of HCl gas in that particular jar. So that's a test for hydrogen chloride. So remember that. Let's move ahead to the next one. What does the method of collection tell you about the density of hydrogen chloride? So what does that tell us? It tells us that hydrogen chloride is denser than air because it easily settles down and displaces air out. So it comes in and pushes air out. So what does that tell us about anything? It tells us that it is denser than that particular element. So hydrogen chloride is denser than air or heavier than air. Let's move on to the next question. Name the gas evolved, formula not accepted. So this is definitely there. Please in the exams do not write formulas in any answer as an answer. Okay, you are supposed to write the entire name. In the bracket you can mention the formula also. So it says that name the gas evolved by the action of concentrated sulfuric acid on sodium chloride. So we have done this equation many times by now. That is NaCl plus H2SO4 gives you NaHSO4 plus HCl. So what is the gas that is coming out? That is HCl gas. Let's move on to the seventh question. Correct the following statement. The statement says hydrochloric acid is prepared in the lab by passing hydrogen chloride directly through water. Okay, so how can we correct this is that instead of directly passing it through water, you use an inverted funnel arrangement to pass it through water. So that is how you can correct it. You use an inverted funnel arrangement. Now next is why hydrogen chloride gas is not dried by using phosphorus pentaoxide and calcium oxide. So again, what happens is that it ends up reacting with these particular elements. Let me give you the equations for it. So phosphorus pentaoxide will be P2O5 plus you have HCl gas coming in. So that will give you POCl3 plus HPO3. And when you have calcium oxide, so that would be CaO plus HCl, that will give you CaCl2 plus H2O. Okay, so instead of HCl getting dried by these particular elements, it will end up reacting with them. So let's move on to the ninth question. The following questions are related to the lab preparation of hydrochloric acid. Name the reactants used. NaCl plus concentrated H2SO4. Next is give suitable reasons for choosing these reactants. The main reason is that sodium chloride, it is easily available and it is cheap, and concentrated sulfuric acid is the least volatile acid. So that's the reason why we are using these particular reactants. Let's move on to the next question. Write a balanced chemical equation taking place below 200 degrees Celsius. Okay students, I'm not writing this equation again. We have done this equation like 4 times by now. So make sure that you take a look pause and go back in the video if you have any doubt. Let's move ahead. Why the temperature of reaction must be maintained below 200 degrees Celsius? Very, very important. So you have two main reasons. The first is that when the temperature goes above 200 degrees Celsius, we get a sticky compound, that is sodium sulfate. Okay, you get sodium sulfate Na2SO4, which is a sticky compound, and it sticks to the beaker, the round bottom flask. It sticks to it, and it is very difficult to clean the apparatus after the experiment is done. So what would happen is you may end up breaking the apparatus, or the entire apparatus may be spoiled. The second important reason is that you are using a lot of fuel to keep the temperature above 200 degrees Celsius, even when you can easily get HCl at a lower temperature. So you are actually wasting a lot of fuel. So that's the second reason. Let's move ahead to the 10th question. The following questions are pertaining to the lab preparation of hydrogen chloride gas. Write the equation for its preparation and mentioning the conditions required. So equation I've already told you. Mentioning the condition required, so that will be that H2SO4 should be concentrated. The second condition would be that it should be below 200 degrees Celsius. Students, why do we have similar type of questions? That is because the same concept was asked in different years but in different ways. So that's the reason I have included all the questions, so you get better idea that just the lab preparation of HCl gas can be asked in different ways, but it's easy. So let's move on to the next one. Name the drying agent used and justify your answer. So what drying agent do we use? Another important thing is name the equations. It should be equations here. So make sure that you mention both the equations, that is above 200 degrees Celsius and below 200 degrees Celsius. Now name the drying agent used. So drying agent we are using is concentrated sulfuric acid. Okay. And the main reason is that it does not react with HCl gas because both are acidic in nature. And if you use anything else to make a better answer, justify your answer. For example, if you use calcium oxide or phosphorus pentaoxide, HCl gas ends up reacting with those compounds. So that is the reason we do not use them as drying agent, and instead we use concentrated sulfuric acid. Let's move ahead to the third part. Name a safety precaution you would take during the preparation of hydrochloric acid. So the precaution, or you can say the setup that you will use would be inverted funnel arrangement, because when you're dissolving it in water, it's easy, no back suction, because if back suction happens, there's a high chance of getting into an accident in which you have the entire apparatus may suddenly break, because when the water goes back, like it's water, so when it goes back you have concentrated sulfuric acid there. So this may end up creating a lot of mess and may injure somebody. So that is the reason the precaution that you will use would be inverted funnel arrangement. Okay students, let's move ahead to the 11th question. Give balanced equation for the following reaction. Concentrated hydrochloric acid and potassium permanganate solution. So potassium permanganate solution is KmNO4 plus HCl, and that will give me KCl plus MnCl2 plus water plus chlorine gas. So this is your reaction. Now next question is, by the addition of only one solution, how would you distinguish between dilute hydrochloric acid and dilute nitric acid? So what solution you can use? You can use silver nitrate solution. I have also taught this in the mind map also. So you can use silver nitrate solution. So what happens in this case is that when you have HCl, it gives a white precipitate which is soluble in excess of NH4OH. But with HNO3, there is no visible reaction. Okay, so I'll just write that for you. With HCl, it gives a white PPT which is soluble in excess, NH4OH, ammonium hydroxide, so NH4OH. Whereas with HNO3, no visible reaction. This is important. A lot of students forget to revise this portion, so make sure that you revise this area from the book or from the notes. Let's move ahead to the 13th question. The diagram below shows a simple arrangement of the fountain experiment. Name the two gases you have studied which can be used in this experiment. What is the common property demonstrated by this experiment? So the diagram is not there, but it's the basic fountain experiment. So let's just quickly answer the question. Name the two gases you have studied which can be used in this experiment. So either you can use ammonia or you can use HCl gas. Both of them have fountain experiments in the chapter. So your answers would be ammonia and HCl gas. What is the common property demonstrated by this experiment? The common property is the high solubility or high levels in which these gases are soluble in water. Okay, so that is the solubility of gas in water. Now the next question is, what property of hydrogen chloride is demonstrated when it is collected by downward delivery, or that means upward displacement? So what do we mean by that? We understand that hydrogen chloride gas is heavier than air. So that is what you understand about hydrogen chloride. Now why is hydrogen chloride not collected over water? So that's very basic, that it is highly soluble in water, so you cannot collect it over water. Let's move to the next question. State the color changes observed when dilute hydrochloric acid is added to the following indicators. So the first is neutral litmus solution, so that will turn red. The next is alkaline phenolphthalein solution, it gets decolorized. So decolorized. Then you have methyl orange solution, it turns red or pink. Red or pink. Let's move ahead to the next question. Give reasons for the following. Hydrogen chloride gas is collected by upward displacement of air. That is because it is heavier than air, so it is easily able to displace air and it can push it out. And the second would be that it is highly soluble in water, so it cannot be collected over water. Therefore, it is collected by upward displacement of air. The next is hydrogen chloride gas is not collected over water. That is because it is highly or extremely soluble in water. For the preparation of hydrochloric acid, hydrogen chloride is not directly absorbed in water. Now that is because it can cause back suction if you are using it, if you are dissolving it directly, and which can cause a major accident or harm somebody nearby. So that is the reason we use inverted funnel arrangement and not directly absorption into water. Fourth part, dry HCl gas does not change the color of blue litmus solution. That is because when you have moisture in HCl gas, we always say moist HCl gas shows a color change in blue litmus. That is because when you have moisture, in the presence of moisture, you have hydrogen ions present. If you do not have moisture, you won't get H plus ions. And H plus ions are solely responsible for the change in the color of litmus paper or any test for that matter, any indicator test for that matter. H plus ions are responsible for it. So that is the reason a dry HCl gas will not show any change in blue litmus. 18th question. Write a balanced chemical equation for the following. Sodium thiosulfate is reacted with dilute hydrochloric acid. Okay, so sodium thiosulfate is Na2 S2O3 plus H2S, hydrochloric acid plus HCl. That will give me NaCl plus H2O plus SO2 plus sulfur. This is an exception equation, so it's important. This is an exception equation that you can find in your book, and it has specifically your sulfur residue at the end, which is right here, which is yellow. So it is specifically there, and a lot of students miss that out. So let's move ahead to the 19th question. Write the equations for the following reactions. Dilute hydrochloric acid and sodium thiosulfate, we just wrote that. The second is dilute hydrochloric acid and lead nitrate solution. So we also did this one, lead nitrate, in the first or the second question, but I will still write it. So lead nitrate is PbNO3 whole twice plus HCl, which will give me PbCl2 plus nitric acid HNO3. Let's move ahead to the 20th question. Write balanced chemical equations for the reactions of zinc and dilute hydrochloric acid. So that's simple. You have zinc plus HCl, that gives you ZnCl2 plus hydrogen gas. Let's move to the next question. What do you observe when hydrochloric acid is added to silver nitrate solution? So when that happens, you get a curdy white PPT which is soluble in excess ammonium hydroxide. I told you that this is an important part in HCl chapter and you may miss this out. So make sure that you specifically read the reaction of hydrochloric acid with silver nitrate and what kind of products form, how does they react, and what kind of output comes. So for example, in this case you have white curdy PPT which is soluble in excess of ammonium hydroxide. Okay, let's move ahead to the next question. Okay, that is it. We have covered 21 questions today. Alright students, so this is it for today's session. We have successfully covered about 21 important questions of the chapter HCl. If you want to practice more questions and not based upon the lab preparation of HCl, I do have the second video coming out in which you have other about 15 to 20 questions which are important PYQs for HCl chapter. So make sure that you check that out as well. And if you have any doubts and queries, don't hesitate to reach out to me either on the Telegram channel or in the comments box, or if you want me to take a look at your answers and tell you if they are good enough for your board examinations, you can definitely write to me on psclassesicsc@gmail.com. So make sure that you're preparing well for your board examination. I am definitely sure you will achieve good marks if you are following the channel well, and if you are working on the mind maps, revising your content well, and doing all the important question series that is already being posted on the channel. So make sure that you prepare well and don't be stressed out. It's gonna be worth it. You are gonna score really well. So thank you so much students. We'll catch up in the next session.